All right, welcome pre-calculus. I am going to be giving you the notes for a second half of Unit 16, so it's kind of in two awkward parts. Circles was the first half, and now the other half is like area, surface area, and volume. So, and when it says part 2, this is just the second half of 16. There will be its own separate test on this. And it won't be combined. We're not going to retest on the other one unless you want to do a retake. First, you're going to see we're going to talk about trigonometry, and this should be a review of SOHCAHTOA. One thing I would like you to do, you will be needing a calculator. So when you turn the calculator on, don't worry about what's referred to as the home screen. You can clear that out if you want. What I do need you to check is most of my yellow calculators that you are going to borrow are okay. What I would need you to do is check mode here. And you can see that my calculator right now, we can do trigonometry in a couple different ways. One is with degrees and one's with radians. When you look at these pictures, you'll see in the corners, they have 75 degrees and 47 degrees. We want to be functioning in degree mode with the calculator. So otherwise, we might get some negative answers and really small stuff. So if yours at all looks like this, arrow down and over till it says degree, hit enter. And the highlighting will take it back over to degree. Now, if you do this, you initially came out and said, okay, press mode, and you're already like this, you don't need to worry about anything. You can press clear and get right back to the home screen and get out of that. All right, so a little review of some trigonometry. So write a trig fraction, the ratio as a fraction. Make sure it's reduced. All right, so SOHCAHTOA, sine, S-I-N, is opposite side over hypotenuse. Cosine is really cosine, or cos, is the adjacent over hypotenuse, and tangent, tan, is O over A. You can see the O's repeat. That stands for opposite. The H's are the hypotenuse, because we are always going to be doing always going to be using right triangles when we do this, and A is for adjacent. All right, so it's like, well, how do you know which one's which? So a little bit of review here. They will always give you what's referred to as the reference angle, and that's the angle you're going based off of. We are not going to use the right angle because trig changes when we use the 90-degree angle. So C is my reference because the problem is we're having you look at C. You always go through it for the opposite side. If you have the numbers, the hypotenuse is the biggest, and then the adjacent is what's left over. So sine, if we're setting up the ratios, I have the opposite over hypotenuse. So I find those two numbers, 24 and 40. Reduced fraction, you can, if you're good at reducing, that's fine. Or 24 divided by 40, hit math, enter once, enter a second time. So 3/5. Cosine is the adjacent versus the hypotenuse. So put them in this order every time. So 32 over 40 and reduce. This reduces to 4/5. And tangent follows the O over the A. So the opposite side versus the adjacent. And this for right triangles will never change. 32, so it's 3/4. So when it's asking you to make the ratio, these are what we're looking for. So if this seems familiar, go ahead to number 2, start ripping through it, and now I'll go along. Here, my angle is Z, that is my focus. If I go through the triangle opposite, hypotenuse is the biggest side as across from the right angle or the slant. And A is for adjacent. Sine Z, so sine is opposite over hypotenuse, so opposite of 20 versus hypotenuse of 29. Always try to reduce fractions. Now, if I do 20 divided by 29, hit math, enter once, enter a second time. If you get the same answer, it means the calculator cannot reduce it. Doesn't mean you have to do something different. It just means it can't be reduced. So we leave it alone, 20 over 29. Cosine is adjacent over hypotenuse, 21 over 29. And opposite versus adjacent is 20 over 21. And those are your ratios there for this triangle. Now setting up to solve, this 75 looks awkward here, but 75 is what I'm going to use because I need an angle. This triangle squished here. This side here is the opposite. This one over here is hypotenuse and this is adjacent. Trying to solve for x. I have a 38 on the opposite side, and I have an x on the adjacent side. Hypotenuse is blank. There's nothing there, so nothing's going to help me, so I'm going to ignore it. So that means I have the O and the A side to work with. So you're like, oh, and A, O and A, O and A. Okay, so O and H, no good. A and H, O and A. Oh, tangent has the O and the A, so I'm going to work with tangent. So set up an equation. Tangent of 75 equals, and put the opposite over the adjacent, so 30 over x. We're gonna cross multiply and solve a little bit here. So over 1, 30, because I'm multiplying the 30 and the 1 together. So I get those two, and then I get these two. X times tan 75. And divide by tan 75. Oops, I guess this is multiplied here together. Tan 75 is a number. The calculator will help you figure it out. It's not something I know off the top of my head because every single angle has a sine, a cosine, or tangent, and they're mostly decimals. Not all, but some. Definitely, I have a lot of decimals to them. All right, so we're gonna round to the nearest hundredth on here. So 2 decimal places. So 38 divided by tan 75 is 8.0. Make the 3 become a 4. 0.0. Oops, that's not good. 8.04. There we go. Okay, if you think you're good, try again and just double check with here. 47 is my angle across. Go through it as opposite. Big slant side across from the 90 is always the hypotenuse. And this is end up as my adjacent. I'm gonna ignore the opposite because it's blank. There's nothing there but the O, so that's not helpful. I have a 29 and X to deal with, which is an A and H. So that is my cosine. So I have cosine of 47 equals 29 over x. It has to be the adjacent on top. I'm always following the patterns. The adjacent on top, hypotenuse on bottom. All right, set this up. I cross multiply. I get 29 equals x times cosine 47. Oh, I gotta get the x by itself. If this is multiplying, I'm gonna divide. (29) divided by cos 47. All right, about 42.52 for that hypotenuse. So top divided by bottom, 42.52. Now, when we're trying to find angle measures, we use inverse trig. When I don't know the angle measures, I use inverse trig. And that's sine -1. They're on the calculator. Cos -1, tan -1. And that helps me, let's get this back. That helps to get angle measures. So, inverse trig, these are buttons on your calculator. You first just got to set it up like you did above. All right, if I'm trying to find x here, I'm trying to figure out that one. I do the same stuff I did before. I go across. This is the opposite here. Oh, 32. Hypotenuse is blank, so you can ignore that. Adjacent here is 24. So I set it up. Tangent of, because I have the opposite and adjacent, tangent of x equals 32 over 24. Now this, I have the x here. I don't divide by tangent. You can't, if you try doing your calculator, divide by tangent, it won't work. So what we have to do is inverse trig, and what happens is you do it to the left and you do it to the right. And what you get is inverse tan, or tan negative 1, and you just do 32 divided by 24. So the two sides in the triangle were that. We do inverse tan here, so inverse tan or inverse cosine, they're in blue here, so press the blue second button, and then that. 32 divided by 24. So if I didn't press the inverse, you would get a small number that's even less than 1 degree, so that's no good. So we're gonna get rid of that bad boy. Oops. Okay, just get rid of all. Okay. Try again. Inverse tan of 32 divided by 24. So I got about 53, and it says to the 10th, 0.1. Now, we can use all the properties about triangles and that sort of stuff. Triangles add up to 180. So if I have 180, subtract the 90, and subtract the 53.1, you're going to get that missing angle at Z. You can also do trig if you want. You don't have to. 80 minus 90. Ooh, that's not. 80 minus 90 minus 43.1. Nope, 53.1. There we go, 36.9 for that other angle. All right, same thing on this next one. Angle A here. You go through, this side is opposite. This is hypotenuse, this is adjacent. Oh goodness, I have all three sides. So if I have all three numbers, you pick two you want to work with. I'm probably just going to pick the O and the H just because we haven't done sine yet. So I write sine. So what I'm doing is sine of the angle. Sine of the reference angle is 35 over 37. What is happening is I technically kind of bring this over here with the inverse. Sine negative 1. And do 35 over 37. So sine 5 divided by 37. Okay, about 71.1 degree for angle A. Then angle C, I'm just going to take 180 minus the 90 degree minus 71.1. And I got that smaller angle is about 18.3. All right, feel free to go back and rewatch any of these anytime you want. If you have questions, of course, let me know. If you feel good about number 7, feel free to go do it on your own. I'm going to do Pythagorean theorem here to get side PQ. It does say for length, so the side round to the 100th. So don't worry about simplifying that radical. It does come out to be, with Pythagorean theorem, about 11.18. And the angle measures. So if I have angle R, I have opposite here, adjacent, and hypotenuse. I'm going to use the two numbers given to me, so the 10 and the 15. So I'm going to do cosine of r, 10 over 15, cos negative 1 of 10 over 15. So angle R says the nearest whole degree. So the whole degree would be about what, 48? And 180 minus 90 minus 48. Oopsie, not that. Okay. Will end up being 42 for the other one. All right, so throwing Pythagorean theorem is coming back. We have trig review. We haven't seen that since last year. The next thing you probably haven't seen for quite a while are these formulas down here. For these, we need to know about altitudes. They are segments that make right angles. So altitudes are segments that make right angles. Sometimes we also know that altitude is height. That's another word you can interchange with it. An altitude, you know, or immediately if you're flying on a plane, your cruising altitude is blah, 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 blah. That means the height straight down to the ground. Altitudes can lie on the side of a triangle, on the side of a shape. So they can be directly on the side of a shape, and that's right here. If we connected these and together, it can be the exact size of a shape, and this can be an altitude. And we refer to the other side as the base, or we can also flip-flop them and have altitudes like that. So technically we do have two altitudes in here, but an altitude, a height here, can also refer to, we can call it a base instead. So altitudes can lie on the side, so that's this picture. They can lie inside, which is going to be this picture. So if a segment is drawn down here and splits there, makes a right angle here, this is an altitude. Sometimes we need to calculate them, sometimes they're there. And sometimes they have to lie outside the shape. Now, if I say, hey, draw from this corner up here, draw from this angle to this side, a right angle, and you try to like, if I do it here, it's gonna slant. So if I do the one like here, I don't have a right angle. If I go down, there's no right angle. So if it has to be from this corner, altitudes can exist, or heights of shapes can exist outside of a shape. This can be your altitude or your height. And technically, only from here to here, this is the base. It's just when there's no way to physically draw it in there, yes, I could draw it from another angle, but if I wanted to draw it from this angle to this side, I would actually have to say the height straight up and down has to be outside the shape. So they can lie any of these places. And this is important because it's going to come up with a lot of heights here in these area formulas. All right, so we're talking about area, and it's going to be the amount of space. Amount of surface something covers. That's the amount of surface that something covers. I didn't want to say space because that kind of gets into a three-dimensional. Right now we're doing two-dimensional. And we always do units, whatever the units are, to the second. That's for the label. Units to the second because we're talking about two-dimensional shapes. All right, this shape, this one here, base 1 plus base 2, this is for a trapezoid. Area equals pi r squared. This is the area of a circle. Letter C, sometimes you might see as 1/2 BH. This is for a triangle. B times H. This one gets a little tricky because it's definitely a rectangle. It's a parallelogram as well. And technically, this also works for a square. See, I see technically because the next one is definitely a square because all the sides of a square are the same, but we could also use base times height since they're all the same, it still works out. All right, so next coming up, a lot of just practice some areas. So take a break if you need to, go through, calculate these, see if we match up. And this one, this is a rectangle. So, and that's 4 times 9 or 9 times 4, so 36 centimeters squared. Now the second one, this is a composite shape. We have congruent pieces, so I'm gonna cut off the piece here. I'm gonna say the area of this piece up here is base times height, so 7 times 10. And the area of the piece down here is 20 times 10, so 200. And if I add up, 70 inches squared. Now this is a parallelogram. Parallelogram is base times height. I don't want any slanty parts. Any slanty parts, no good. The base is here, and you can see that straight up and down line, that's your altitude or that's your height. So 10 times 6, so 60 inches squared. Here's another one on a triangle though. See, this is what I was referring to. I can't draw, this height is drawn in here. This is your height here. It connects or it tries to connect. This is your base. The slanty stuff, no good. All right, so our area is base times height divided by 2. So 16 times 16 over 2, and that's 256 divided by 2. I don't know what that is. 128. There we go. All right, some of these you're gonna have to work backwards, work backwards, work backwards, work backwards. Missing base, area of the shade is so a lot of work backwards. So rectangle, area, height. So 98 is equal to base times 7. Divide by 7, work backwards. 90 divided by 7 leaves me with 14 inches. Again, at number 12, you have a rectangle. Oh, that's the same question. That's super silly. Ignore that one. Whoops, daisy. Hope you got the same answer. The next one is find the height of the trapezoid with the total. So total of both bases. So base 1 plus base 2 already equals that much. And the area is this. So here's the formula. Base 1 plus base 2 divided by 2 times height. All right, our area is 200 is equal to both bases together. So both of them already together is 25. I don't need to worry about what the separate numbers are, but they're both 25. All right, if I divide this out, I get 200 equals 12.5 each. Divide that out, solve for the height. And I get 16 centimeters. All right, the missing base in a triangle with an area of that and a height of that. All right, triangle, base times height over 2. Area, I get 143 is equal to base times 11 over 2. You can divide those numbers out if you want, or you can just multiply the 2 to both sides, that's fine. 286 is 11 times the b. That comes out, actually the base comes out to be I was thinking it was a decimal, but it's not. 26 inches. So when you're finding one direction or one dimension, it's just the plain label. Now the area of the shaded region here. All right, so shaded, so we need to do the triangle shape, and then we need to do the inside square. All right, so 10 times base times height divided by 2. It doesn't matter the order you do them. That's 70. The square is cut out of the middle of it. So that's 25. And if it's cut out, we don't want it as part of our numbers. So we're going to subtract it. All right, so that's it. Oh, no, just one more. Sorry. We're going to hold off on doing some of the trig combination stuff till next week when I'm back so we can make sure we got that and move on. So we're going to stop right here. Because the one thing I did want to talk about is we will bring these back. A circle with an area. Oh, determine the area. Diameter is equal to 18. So the radius is 9. For the nearest tenth, so exact. All right, so the formula is pi times radius squared. So the area is pi times 9 squared. Anytime we have a number squared, we're just going to do it and figure that out. And we get 81. And we leave pi alone because pi is a decimal. And if without making a decimal, we can just leave the pi symbol there and have that as part of the answer. That is what an exact would be. I leave as 81 pi and we're good. I should put a label though, centimeters squared. Now approximate means I'm actually going to take that 81 and multiply by pi. And it says rounded to the nearest tenth. So I have 81 times, pi is over here, it's on the division, above the division. So I hit blue and then the caret key. And to get 254.10, so 0.5. So that's what it would be if I would multiply these two out. I would get those two about that bigger number there. All right, email me if you have questions. You can stop there. The homework is going to be modified. Don't do all the homework, but I will post what I'm looking for to be done, and then I will get answers up for you. Have a good weekend. Bye.